Waste, a topic that raised the tricky question of what to do with it, was already relevant at the time of Jan Neruda's classic. And there have been more and more question marks raised about waste ever since. In proportion to the increasing volumes in today's consumer world. It is estimated that more than 1.3 billion tonnes of waste are produced annually on Earth these days. That equals 4 times the weight of all the people on our planet. The largest producers are the richest countries in the world, led by the USA. And how do we rank? Each Czech produces 537 kilograms of municipal waste a year. However, this amounts to just 1/5 of the total Czech waste production. Another 4/5 are produced by industry and other operations. Under the law, this waste must be handled responsibly by its producers. Waste from households, commerce and services, the so-called municipal waste, totals 5.7 million tonnes per year. About 40% of this waste is sorted by people into colour-coded containers and in waste collection centres. It is then recycled or composted. And what about the non-reusable waste residues? A modern and preferred solution to this is waste to energy. Waste recovery, or its legitimate disposal, is also a hygiene obligation. A conventional incinerator only serves to inertize organic matter in waste by incineration, but incinerating can get smarter. Energy from waste is based on thermal treatment of waste and subsequent heat and electricity generation. These facilities are subject to very stringent European and Czech laws defining technical conditions for the operation and strict emission limits for the monitored pollutants. Waste-to-energy facilities are now part of modern waste management in many developed countries, including the Czech Republic. At the end of 2014, the European Commission adopted a legal framework for the so-called circular economy throughout the EU. It is based on the fact that we must think about the maximum possible use of everything that the product contains at each and every stage of the product's life cycle. This covers the raw materials, design, production, distribution, use, collection and recycling. Despite the best efforts, there is always some residual waste left at the end of this cycle, and even the residues must be recovered to the maximum possible extent. To produce energy, according to data from the European Association CEWEP, there were 492 waste-to-energy plants operating in Europe in 2017. Currently, most of them are in operation in France and Germany. The situation in Western and Eastern Europe is not the same. While in Belgium, for example, 18 waste-to-energy plants are in operation and serve over 11 million inhabitants. In Hungary, there is only one plant for just under 10 million people. Denmark, which is smaller in size and population than the Czech Republic, operates 26 waste-to-energy plants. The Czech Republic has only 4. The general trend in developed European countries is to reduce landfilling as much as possible and protect natural resources. In a number of European countries, such as Germany, Austria, Switzerland, France and others, landfilling of untreated municipal waste has been banned for many years, and most waste is used for energy production. The 4 waste-to-energy plants currently operating in the Czech Republic are in Prague, Liberec, Pilsen, and the only one in Moravia and Silesia, SAKO Brno. How do we care about waste in Brno? The second largest city in the Czech Republic treats its municipal waste in a very responsible manner in all aspects. Thanks to our sophisticated system, only less than 3% of municipal waste production is put in landfill. Municipal waste disposal in the city of Brno is based on the principle of strict adherence to the following hierarchy. Primarily, it focuses on the reduction of waste production and its preparation for reuse. This is followed by recycling, energy recovery, and finally landfilling.
SAKO Brno je akciovou společností a jediným akcionářem je statutární město Brno. Dlouhodobě patříme mezi nejstabilnější společnosti v jihomoravském regionu. Poskytujeme komplexní služby v oblasti nakládání s odpady, jak právě pro město Brno a přilehlé obce, tak pro obchodní společnosti i živnostníky.
Waste collection and the distribution of energy for Brno are ensured by 500 employees. SAKO has a modern fleet of vehicles, a sorting line and state-of-the-art waste-to-energy technologies. And which waste is the best? The one that is not produced at all. This is a smart and responsible idea. Discarded but still functional items are given to those who need them and can still get some use out of them. Based on this principle, several reuse projects to benefit the public have been ongoing in Brno. SAKO Brno collects waste from the city and its surroundings into two facilities, the waste-to-energy plant and a sorting line. Since 2023, this line has been semi-automated and is the first of its kind in the Czech Republic. Where previously sorting was done only by hand, the automated process is now much faster and more efficient. A system of separators recognizes plastics by shape, composition and even color. It sorts the content of the yellow containers into 10 commodities, such as PET bottles, polypropylene, polyethylene, Tetra Pak and others. Magnetic and inductive separators extract ferrous and non-ferrous metals, such as food tins and beverage cans. The new line can process the contents of 2 full garbage trucks per hour and up to 15,000 tonnes of pre-sorted waste per year. It serves not only the city of Brno, but also other municipalities. This way we can now capture everything that can be recycled and ensure maximum utilisation of the sorted waste. The second facility located at the same address is the waste-to-energy plant. Let's go through the whole process from the very beginning. The journey of every waste starts on the weigh station. Weighing is automatic and is processed by special software. Collection trucks pass through a detection system that can detect sources of ionizing radiation. As a result, no radioactive materials hidden in the waste will enter the site. Waste is then transported from this weigh station either to the sorting line or for energy recovery based on its qualitative composition. A collection truck with unreusable waste heads towards one of the 8 unloading pits and the content is dropped into the bunker with a capacity of up to 5,000 tonnes. This is the volume that the boilers can burn in about a week. A similar volume is produced over a year, for example, by a municipality with 3,000 inhabitants. Larger items are first fed to a shredder. A number of municipal waste analyses are performed 4 times a year in order to determine its qualitative composition. From a chemical point of view, the waste brought to the site contains almost the entire periodic table of elements. 2 polyp grabs extract waste from the unloading pits. First, they homogenize everything so that the resulting mixture has a similar calorific value. The grabs then feed the waste to individual boiler hoppers. A permanent weak underpressure is maintained in this bunker by sucking out the air which is used in the incineration process. As a result, the waste smells less and no dust is formed around the bunker. In the boiler room there are 2 vertical 5-pass steam boilers with reciprocating Martin-type grates developed specifically for solid municipal waste incineration. The waste passes through a water-cooled hopper and by means of a feeding device with a hydraulic drive is evenly distributed on the combustion grate of the boiler with an area of 45.5 square meters. This solution enables the setting of the optimal incineration regime according to the calorific value of the incinerated waste. The grate bar's movement spreads the waste over the entire grate area. This ensures a perfect burn of the combustible waste components and a low production of pollutants. The usual calorific value of waste as a fuel is 8 to 11 megajoules per kilogram. SAKO supplies around 1 million gigajoules of heat per year to 100,000 Brno households connected to the district heating network, which covers 1/3 of their consumption. We supply around 50,000 megawatts of electricity per year to the power grid. The whole incineration process is controlled from the central control room. For a cold start, the combustion chamber must first be heated to 850 degrees Celsius using a natural gas burner. Waste fed to the preheated combustion chamber ignites immediately and no additional fuel is needed. Waste remains on the grate for an average of 30 minutes. However, oxygen is needed to ensure complete burn. Therefore, preheated primary air is fed to the boiler under the grate and secondary air over the grate. The boiler itself is a water tube boiler with natural circulation and 2 drums interconnected to the evaporator and a 2-stage economizer. This is designed to ensure adequate flue gas retention time in the boiler combustion chamber. Organic matter burns down to carbon dioxide at high temperatures of 1000 to 1200 degrees Celsius, which prevents it from forming new thermostable organic matter. From a chemical point of view, the combustion process is an exothermic reaction releasing the maximum possible heat. The released thermal energy is transferred to the boiler water system, which produces high-pressure superheated steam at a pressure of 40 bar and a temperature of 400 degrees Celsius. Superheated steam passes through a steam condensing turbine which has one controlled and one uncontrolled steam extraction. The high-pressure superheated steam expands in the turbine and the kinetic energy is transformed into mechanical energy, driving the rotor blades to about 6,800 revs per minute and transmitting the mechanical energy through a shaft to the gearbox, which reduces the revs per minute for the generator. The generator transforms mechanical energy into electricity.
Regulovaný odběr páry ze středotlakého dílu parní turbíny o tlaku 11,5 baru je v technologickém procesu využíván na ohřev primárního vzduchu podrožd kotle a ohřev napájecí vody kotle. Největší množství této páry je využíváno na výrobu tepla do soustavy centrálního zásobování teplem. Menší část páry je dodávána přímo do parní soustavy a větší část páry je zavedena do horkovodní výměníkové stanice o nominálním výkonu 56 MW, která ohřívá vratnou vodu ze soustavy CZT.
The air condenser with a nominal output of 51 megawatts allows the boilers to be operated at a constant output regardless of the heat consumption in the district heating network. The steam from the final stage of the turbine is fed by a steam pipeline to the air-cooled condenser, where it is distributed into 4 sections. Each section has its own fan with a diameter of 10.4 meters, which drives cool air through the rib tubes. This is where heat is transferred by forced convection. Outlet air is heated by approximately 5 degrees Celsius and the steam gets condensed. The condensate returns to the steam production process. To enable periodic monitoring of qualitative parameters of the feed water for the boilers, the boiler water and condensate, an operating laboratory equipped with state-of-the-art equipment, has been established. Bottom ash is an inert inorganic material remaining after the combustion process. Bottom ash falls from the boiler to the bottom ash extractor with a water trap, ensuring that no uncontrolled air can be sucked into the boiler. Here it is cooled and a belt conveyor transported to the bottom ash line. The line separates ferrous and non-ferrous metals, especially aluminium and copper, which are transported off-site as secondary raw materials for recovery. Bottom ash is divided into different sized particles. It is then reused in landfill structures. The mission of SAKO is to ensure such bottom ash quality parameters so that it can be used as a building material and thus waste production can be minimized. Waste loses 3/4 of its weight during the incineration and 90% of its volume. For comparison, a full black dustbin results in a bucket of bottom ash. A ton of waste transforms into 220 kilograms of bottom ash and 30 kilograms of metals can be separated from it. Some people are worried about smoking stacks, but unnecessarily so, because in SAKO the whole process is under strict control. Flue gas cleaning system forms an essential part of the technological process, consisting of 5 stages. Thanks to this, only a trace amount of pollutants is vented out into the atmosphere. These are only thousandths of a % of the total volume. For comparison, the results of measurements made by the Czech Hydrometeorological Institute show that, for example, the concentration of harmful benzoapyrene in small municipalities in the heating season is usually up to 18 times higher than in Brno, with all its transport, industries and, of course, our facility.
Pro ještě lepší představu se podívejme na odpad jako Mendelejevovu periodickou soustavu prvků. S nejrůznějšími druhy odpadu sem přichází téměř celá. Mnohé z těchto látek bychom si ve svém těle nikdy nepřáli. Díky 5stupňovému systému čištění spalin zabráníme úniku těchto látek do atmosféry. Některé dokážeme chemicky rozložit, jiné navázat na produkty čištění spalin a následně je mechanicky odloučit. Výsledný pevný produkt se zakoncentrovanými znečišťujícími látkami předáváme odborným společnostem k dalšímu zpracování.
Let's take a closer look at this process and study the chemistry behind it a bit. The bound organic carbon reacts with air oxygen at high temperatures to form carbon dioxide and water with a release of heat. The incineration process is also accompanied by reactions of biogenic elements contained in the waste, such as nitrogen, sulfur, hydrogen with oxygen, and chlorine and fluorine with hydrogen. The first stage of flue gas treatment is based on the principle of selective non-catalytic reduction and ensures a significant reduction of nitrogen oxides in the flue gas. The system uses the reducing properties of a 40% aqueous solution of urea, which is injected into the boiler combustion chamber in areas where the flue gas temperature is in the range of 900 to 1050 degrees Celsius. Nitrogen oxides are formed during the reaction of oxygen and nitrogen, which comes primarily from 2 sources: fuel, for example, from biowaste, and from the air. An undesirable chemical reaction accompanying surplus urea is the formation of gaseous ammonia, the so-called ammonia slip. The reduction of nitrogen oxides concentrations after urea injection into the combustion chamber can be briefly described by the following chemical reactions. The second stage of flue gas treatment uses activated carbon, which combined heavy metals and dioxins to its surface. Heavy metals enter waste on metallized objects or are part of dyes and get released during incineration. Activated carbon also retains unburnt or recombined organic matter, including toxic polychlorinated biphenyls, polyaromatic hydrocarbons and dioxins. The third stage of flue gas treatment, the so-called semi-dry lime method, is based on injecting finely sprayed aqueous lime suspension into the flue gas stream. This so-called lime milk is used to neutralize acidic components formed during thermal reactions. The fourth stage of flue gas treatment is based on the dry lime method. It starts automatically in the case of increased concentrations of acidic components in the flue gas. Dry calcium hydroxide is blown into the flue gas under pressure, and this increases the treatment efficiency to the required parameters. The fifth stage of flue gas treatment consists of fabric filters. This is where the last chemical reactions take place and where all mechanical pollutants are trapped, such as fly ash, flue gas, treatment products and surplus reagents. This fine dust is called the end product. It is pneumatically blown into silos, from where it is transported off-site as hazardous waste in special trucks for further processing. Before entering the stack, the treated flue gas is monitored every second by sensitive analyzers, and the treatment process is controlled by an automatic control system based on that data. The flue gas treatment efficiency is 99% for most pollutants. SAKO Brno works and serves the current needs of Brno, the South Moravian and neighbouring regions. We have a clear vision and plans for the future. we respond to new requirements, goals and developments in waste management through constant innovations. The district heating network is many times more efficient and beneficial for the environment than thousands of local boilers. With regard to global warming, the municipal waste-to-energy process is CO2 neutral. Electricity supplied by SAKO covers a one-year consumption of 20,000 households. In the summer, SAKO supplies heat for the entire district heating network, and in the winter months it efficiently correlates with other sources in the system. It is also part of the critical infrastructure of the South Moravian region in the case of a blackout. In the past, people treated waste as something that was just put in containers and were not interested in its fate. We at SAKO Brno are proud that thanks to our meaningful projects and raising public awareness, the way of thinking is changing for the better. This shows that minds and boilers alike are on fire at SAKO.